morning and welcome to the first of this morning's panel discussions. The importance of an integrated factory solution and changing the EMS market. The building blocks are already here, standards and now in place to electronically control the line speed, assisted changeover and basic machine communications. On top of this, many system vendors have mounted their own bespoke software solutions. And some of them have even gone a step further. They've got their own MES systems. So what are the strengths and the challenges of this approach? Joining me to discuss this morning, we have, to my extreme right, we have Michael Ford from Aegis Corporation. Welcome, Michael. And to his left, we have Clemens Jargon from Mycronic. Welcome, Clemens. So maybe we can get started and basically ask the obvious question: why reinvent the wheel? Why don't we use existing MES solutions? I mean, MES systems have been around for a long time.
Yeah, and that's kind of their weakness, because most MES systems that we see in the market, they are based on code that was written in the last century in some cases, and people have been trying to put them together to become this larger, more kind of holistic system. But in reality, they've been facing limitations. Mm-hmm. So as manufacturing has changed, I mean, it's a business-led change. The fact that we are coping with high mix and low lot sizes, and we have to do extremely flexible production like your machines easily support, it's changed the paradigm of manufacturing. And so the MES control is also changed in its paradigm. So instead of working like a clockwork function like ERP did back in the day, working in month by month by month, now we're working day by day by day. And being able to analyze the data and respond and optimize the factory in near real time is something that they were simply never built to do. And so therefore we've had to reinvent the way in which MES behaves for manufacturing.
Right. But Clemens, I mean, at Mycronic, you're working with existing MES systems and trying to make that to integrate with Mycronic systems. Do you feel that's a right approach, or do you think you need to develop something?
Yeah, I think that's a good question. And on one hand, I agree to Michael what he said. I think MES systems have been around, but they have to be kind of reinvented. They have to be improved. And I think that the MES systems which are around are very generic ones. But generic MES systems are good, but they do what a generic system can do. It provides generic improvement. But in today's world, all the machines from suppliers are very intelligent, they are very smart, and they all have their competence and knowledge. And I think that there's always a need for generic MES systems, which we also have already, but there's always a need for an interlayer, an interface between the machines, also kind of small MES to connect the generic ones and the machine manufacturers to really improve the maximum of knowledge and competence out of the machines.
Right.
And I think we as an industry on the generic MES side and also on the supplier side, we have still a lot to do to improve to best customers' satisfaction.
Right, but Michael, is that not something that CFX is doing? Acting as that sort of interface in one way, or have I got it back to front?
No, it's absolutely right. CFX is a kind of bridge that we see between let's say the machine layer and the factory layer. On the machine side, we see a huge amount of value available to machine vendors who want to be able to exchange data between machines to prepare for the customer a totally optimized environment, which is what you provide with your machine-based MES. And this delivers huge value and differentiates machine vendors. However, that environment, no matter where you draw the line, has to also interact with the factory, which is what you're meaning with to look at the other. We don't call them generic MES systems. There are a lot of generic ones out there. But MES systems which are specifically designed with CFX to be able to deliver the value to machine vendors and give them what they need. For example, a material will come in with a different orientation. Without that link, the machine would stop because an adjustment would have to be made. Right. However, with CFX, our MES system, for example, will inform that this change is coming, and you've got time to re-optimize the environment. So the exchange of information between the factory level, intelligent, modern MES and the machine vendor controlled MES environment is that key for success. And CFX is that native bridge between machine vendor and the factory layer.
Right, okay. So, what's the next evolutionary process to develop AI-driven systems? Are we going to, do we need to develop these AI systems to further automate and optimize the process?
Yeah, we are seeing examples where information exchanged between machines. Now that it's reliable and controlled, and you can do it between any machine without any concern, we suddenly have the opportunity to develop some really innovative software. So machine vendors are doing this, solution providers are doing this, because that data is reliable.
Right.
Now, how far can we go? And it's certainly going to be a step-by-step process.
Right.
We need to see what is going to be comfortable for people to use and understand, that's going to deliver value, cost effectiveness.
Yep.
But basically the door is open now, and that's the real thing that's changed as part of this revolution with CFX and Industry 4.0, in that we've all got the opportunity to do this, machine vendor, solution vendor alike. So this is the great change in the industry right now.
Right. Yeah, I mean, AI is very much in its infancy, Clemens. I mean, as we mentioned before we came on stage, the European Union have just introduced a set of guidelines for developing AI because they want to get ahead of that technological race. Is this something that companies like Mycronic will be paying attention to?
Yeah, definitely. I think on one end, I think we have to be careful. I think, as Michael said, I think we have to define where we draw the line between intelligent machine, intelligent software, given human-made algorithms, and real AI. And I think we have still a lot to be done on professional analysis of data to give accurate information to customers. And then we have to see that we make it more and more intelligent, more and more AI over time. But we need to control this, and that's exactly what EU is doing. EU drives us to be trustworthy in creating AI. We can't give our hands in the hand of our competence in the hand of an AI, which is getting out of control. And EU wants us to be trustworthy. EU wants to have data which can be where we have the information. Who was the resource of the AI?
Right.
Who created AI? And as long as we assure this, we assure what the EU wants to do. And that's definitely one of the cases we at Mycronic are doing. We are following these rules and guidelines, and that's important that we all together do that.
Right, so you want to see a clear track back to who designed that AI system. And if there's a question arising out of that procedure, that it can actually trace back to a human decision at the end of the day.
Yeah, the way I define AI is that if you have a set of data and you feed it into an algorithm and you get a result, maybe you do that again and you put the same data in, the same algorithm, you get the same answer. That's an algorithm. A software developer thought about that and he set up the constraints such that that is the result. There's a very clear responsibility there. However, when you get to the point where the software will create a different result given the same data, now who is responsible for that? Because the person who developed the software did not specifically design that outcome, but the outcome was created as a result of what the developer did. And so you could argue, well, that developer needs to be responsible for the fact that he's allowed that piece of software to make a decision which has had a certain impact.
Right.
Now, that is, I think, the gist of what the European guys are wanting to get together. And it basically follows, Asimov's 3 laws of robotics, and that is really a great benchmark that survives even today.
Right.
So it's good that we're thinking about this. It's good that these rules are in place as guidelines for everybody to follow, because everyone in the industry wants the assurance that with all this new technology that we're making, that it's going to be safe for them to use. There's going to be that audit trail back in case any problems happen, that they can be corrected. Because taking away that layer of unknown is really a key to getting the industry investing in this technology.
Absolutely, yeah. So I think that's a very good description of what AI really is at the moment. So let's turn our attention to the actual automation that's taking place on the line itself. Do we need to start collecting more in-depth test data from post-reflow, like in ICT and areas like that, to get more, to improve our results further up the line.
Definitely, I think as more data we gather, as better the results will be. But it's not about just collecting more data, it's about collecting valuable data. And I think this is the most important. We should not collect data just because of having more. The question is what brings the data, yeah? Which more intelligence, which more competence, which more knowledge we gain about the process. And because as more data you gather, as bigger your solution space will be. Yeah,
yeah, but how do you know you're not going to need that data in 5 years' time?
That's the reason why we have to gather data, but always have in mind, I think, what's the true value behind. And I think that's something what we, for example, do with the SPIs when we look at the solar paste deposition and the AOIs, when we look at the component placement. We're gathering all the data. Most of this data is already used today, but some data we may use in 5 years. That's definitely true.
Yeah, okay. Post-reflow test data.
It's absolutely essential for the guys who design products. I mean, let's take it back to the business side. People who are putting products into the market need to have the assurance that the product is going to perform exactly as they intended from the design stage. So they don't want any surprises.
Yeah.
So a lot of the issues will come from the material selected, alternatives and things like that, and how they affect the processes through which the boards go through. And so sometimes issues will happen in the market which are just intangible. They just don't have any idea on what is happening. But over time, if you do collect that data, you can start to run analysis to understand, okay, what impacted the variation in my intended design here? Was it a process-driven issue? Was it a material-driven issue? Can I now design an algorithm in my process to compensate for those events when they happen so that I can increase that reliability? The total business drive, taking raw materials to a finished product, is clearly wanting to drive that cycle now, to connect the entire design through manufacturing and back again flow. And that isn't just something that's in the domain of MES or design. That's something which we all need to work together to be able to action once we have the analysis of the data. So we are seeing a huge demand for people to collect data from these processes post-SMT. And of course, CFX is supporting all of those processes, can bring the data back and then utilize it for that analysis and drive process improvement that we used to do in the old days manually when there was obvious problems to be solved. But today the problems are too difficult to find by the human eyes and ears.
I think the manufacturers need the information in real time. They don't want to have a meeting a week later to say, well, this is how much scrap we produced last week.
Yeah, they don't want to know how much we lost.
Yeah,
we want to know how much are we going to prevent the loss. Exactly.
Correct. Yeah.
I think that the time we invest in gather more data should be in balance with the time we invest in analyzing the data. I think, and as long as we have this in good balance, then there will be finally a true value.
I think it just comes down to hiring a good data analyst, because that is really where the bottleneck is in the process, is making good, intelligent information out of the data and being able to interpret it properly.
Yeah, there are some interesting software developments going on, true AIs out there in the market now, a lot of famous ones. Wouldn't it be great if we could feed them the data that they needed to start to act? Because it's like there's a brain out there that's looking for something to do. We've got the data, let's put the two together. It's going to happen.
It's going to happen, yeah. So, I mean, the holy grail for the industry is the lights out factory. What are the bottlenecks for preventing this from happening?
This is a good question, so we all want that, lights off. One could argue, I think it's about software. But I would also argue it's about hardware, because today's hardware is pretty much human interface driven. And as long as we are not able to reinvent hardware in a way that we don't need human interface anymore, you can't switch lights off. It's more or less like, look at the car industry. You can improve the cars to be more and more self-driven, more and more automated, but you can get to a stage of level 3, level 4, but to get to a stage of level 5 to be truly automated, we have to reinvent the car to make sure that it really works, safe in the environment we need it. And that's the same for the SMT. I think the human interface have to be designed out of the hardware to really make finally the factory slide off. And I think we have to look also at entire infrastructure. Yeah? So question can be, as long as we deliver zillions of components on reels, can we make it lighter? Yeah? Is the reel the way of bringing components to the machine which gives us the possibility to go for lighter factory?
Right.
Or do we also have to reinvent the entire infrastructure? This is not yet there and has to be driven. So on one hand, the answer could be the software, but I think it's also pretty much hardware driven to get to that stage.
I think you're right, Clemens. I mean, the whole idea of how we automatically feed components onto the mounters is a huge one. So it really is.
I don't see that as so much of a problem. If you look at the machines around, I mean, your machines and the machines we see here, there's some amazing technical innovation going on.
Oh, for sure.
How hard can it be to get a little square bit of plastic into a machine in a known orientation and position? It's just a matter of the redesign. So I believe that is going to be solved.
It's a very complex one, Michael,
is.
because I mean, you can have, one small example is you can have a batch of 0402s, for example, on a reel, and then it runs out and you replenish it, but the next reel's from a different manufacturer, and sizes are just minutely different.
Do we need a reel?
Well, maybe
Go
not.
back to basics.
So you're going to need intelligent pickup, is what I'm really getting at. Using a vision system for intelligent pickup.
There we go. Yeah. And there are systems that vibrate components into known orientations and positions. You put a camera on the machine, boom, 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 knows where it is, picks it up. Can it work fast enough? I'm sure you can develop that. I mean, sorry, I don't want to put you on the spot there. But the kind of technology I'm seeing is definitely getting to be that advanced.
Right.
I understand that somebody who makes software
It's
can
easy.
imagine how complicated it is to get a component on the road. But I think you're right. I think that's something we have to solve. And we have already come close with our feeder system. We may have the most advanced one, but you still need a couple of seconds to change a reel here to get the component. But that's exactly what I said. The hardware challenge have to be solved. And I think then the rest is on software. And then we will soon be then, in a couple of years, be able to provide the first lighter factories.
Okay.
That's our task.
There is one more thing, and it's the word we don't like to talk about, the M word, maintenance.
Maintenance.
Because no matter how wonderful our equipment is, at some point it's going to need adjustment. And that adjustment, until we train robots to go and do the maintenance, we need to do it manually. A lot of the maintenance work that we do can be taken out by the design of the equipment so that it becomes more and more reliable. But ultimately, something will have to be done at some point. And so using the data from the machine itself, being able to understand the workload on each component of the machine, and to be able to work out the life expectancy and feed that data back directly through to a vendor, so that the management of spare parts and the management of maintenance cycles can be automated.
Yeah, I mean, maintenance has to be more intelligently scheduled, because there's so many times when a factory is operating, a line is operating, and a maintenance guy walks in and says, "Oh, we have to stop the line because I need to fix this machine." It needs to be more intelligently managed, for sure, going forward. So, if the future for the industry is going to be less operators in the factory space, does that mean that the machines in the factory themselves are going to change? I mean, do we need as much of the human safety factors involved in it? Do we need the casings on the machines, for example? I mean, what is that going to look like?
Well, you said about removing the human interface. I think that's really interesting because, in a sense, we shouldn't need it anymore. The machine should be aware that the person is there. I mean, we have sensors being developed to do that now. But also, operators, it's not going to be like one operator per line or one operator per two lines anymore. It may be just one operator per factory.
Right.
And so using technologies such as augmented reality, for example, will bring the data to the operator rather than it being based on where the operator is.
Right.
So you have one screen effectively for everything.
So the operator can be less expert in each specific machine, but can be informed using the AR systems.
Absolutely.
To let them cope with more, basically.
I think the operator can be less expert, but then the expertise has to move to another area. I think everything has its cost, and when you may save some money on the operator safety, you have to add more cost and money on the process safety. Yeah? So somehow everything has its price tag.
Yeah.
And the question is now, finally, I think, how about increasing productivity while keeping process stability and process safe? Yeah?
Right.
And trying to avoid human failure, yeah, but keeping process competence and process stability. Yeah?
Right.
So finally, you're saving somewhere, but you're adding costs somewhere else. Our overall task is productivity gain and process stability. And there we definitely will win over time.
Okay. So, final question: where are we going to be in 5 years? You know, put your look in your crystal ball and say, where are we going to be in 5 years' time?
I think the real change is going to be how humans behave in the factory. We're going to see this kind of knowledge being supplied by experts remotely. We're going to see operators having a much wider scope of responsibility. We're going to see machines being able to be much more automated, much more flexible and reliable. But that's all the technical side. Right. What we're really going to see in terms of a business is that people who today are a little bit afraid of moving forward, of making changes, because even a small change in somebody's supply chain can result in an absolute financial disaster, virtually overnight. So a lot of people are very reluctant to change. I think our job right now for the next 5 years is to introduce this technology in a way that people feel comfortable, to be able to drive the will in the industry to meet the demand of the customer, which is to move forward with these kind of technologies that machine vendors and ourselves are providing. So I see the next 5 years as being, okay, we've opened the door, we've got connected factory, we've got plug and play machines now, we've got a lot more data than we used to have. Let's build the confidence in the owners of the factory, owners of the business of manufacturing, and help them use that technology to deliver what the customer needs. Because it's right there, right now, and it's ready to be developed and started to use. So in 5 years, much nicer situation in the industry.
Well, I think it's very much been driven at the moment by the tier one companies. They're the people who've got the volume and I guess some of the deeper pockets, etc., to really take this on and develop it. It's just going to be a trickle-down effect to the smaller manufacturers. So, I mean, where do you think we'll be in 5 years, Clemens?
Yeah, so where are we in 5 years? If it's 5 or 6 years, so my thoughts are we need to strive for a fully automated process from the customer thought of an idea of a product to production. When he thinks and imagines what he needs, we need to be able to deliver to his thoughts. And that's what we have to work on. And we discussed before, there's a lot of things to be done on hardware, on software, on artificial intelligence, but also always on customer communication, customer interaction to really fulfill his needs. In 5 years, I can imagine the first LiDAR factory to be in place, maybe only in high volume, in smartphone manufacturing maybe, no interface, no changeovers, that's something what can be lights off. In the high flex market, I don't think we will be there already in 5 years, but even here, we have already some tools we are providing. We have, for example, also Center of Excellence in Silicon Valley, where we are doing deep learning, where we work on all these ideas. In 5 years, we will be a significant step ahead, driven by customers' demand and by factories' competence and capability.
Okay, so like this vision of the future slide that you've got here.
That's, I think, our vision here, that the technology company have an idea about a digital service. They provide this information via ECAD file to a production company. We produce based on their thoughts and ideas, and we deliver to his expectations.
Right, excellent. Well, gentlemen, it's a topic I could talk about all day. Unfortunately, we don't have all day. So for now, I want to thank you for joining us today. So Michael Ford from Aegis and Clemens Jargon from Mycronic. And thank you for joining us today.